let's get started on the meetup for today. And before we do that, again, a few things about Egen. So Egen, at Egen, we are a cloud and data engineering experts who are trusted by some of the top clients within Chicago, within Midwest, and some across the United States as well. What we do, we modernize enterprises. We help unicorns to quickly scale up. Mostly these are unicorns from Chicago area that we have been part of. And then, of course, launch digital platforms for disruptive startups. These are the entrepreneurs who are probably doing it for the first time, maybe second or third time, and then they want some technical help end to end, and that's where Egen is providing them as well. So we work with enterprises, we work with unicorns, and then, of course, brand new startups as well. Uh, we are based here in Chicago, or Naperville, I should be specific. And then within the last 5, 6 years or so, some of the domain expertise that we have built on is actually within industrial IoT, working with one of the largest OEM in the world, dealing with real-time sensor data or machine data, but then also talking about some of the new industry terms at that point of predictive maintenance, asset utilization, fuel management, component life tracking, operator monitoring, and things like that. In the last 3 years or so, we also started working with some of the healthcare startups, which eventually became Unicorn and some other enterprise companies as well. And of course, there the problems are a little different. You will not get real-time data there, but mostly you are getting batch data with structured, unstructured, or file. You are dealing with genomics data. You have very legacy data interchange formats. And then, of course, you have HIPAA and PHI compliance and other sort of requirements as well. So a lot of work on obfuscation, de-identification, data sharing agreements, and things like that. Last couple of years, we have also started exploring a lot of it now in retail as well, where, of course, pretty much dealing with the e-commerce and fulfillment flows for the grocery companies or grocery retailers, some other kind of retailers as well, payment integration, POS integrations, you name it, and we have been doing it. The whole idea behind doing all of this kind of work, the philosophy or the principles of the engineering are still the same, whether dealing with event-driven architecture using possibly some of the best frameworks to deal with it, whether it's Apache Kafka or in some smaller use cases, dealing with some pub-sub services from the cloud providers as well. Modern data pipelines, mostly orchestrating using Airflow or some of the other modern ideas from the cloud services. Microservices, serverless architectures using not just in the field of running functions on Lambda, but then also running databases in serverless fashion on AWS Aurora, CI/CD operations in the serverless fashion. So a lot many things around that. Automation, observability, and then of course trying all of those things either using managed services from cloud or open source frameworks available out there. So that's about Egen, and that's of course what shows up in our technology stack as well, whether it's dealing with the JavaScript stack end to end for most of our projects, not just for the front end or the mobile apps, but then also for the core backend services. Again, RESTful APIs or PubSub and things like that. Some of our previous work, but then also even enterprise work right now is also around Java, JVM, and then of course Python text center stage seed for the lot of our data engineering work. Some projects still here and there with .NET and Ruby and Rails as well. In the last 3 years or so, I would say most of our new customer work started with the last 3 rows of this slide, specifically focusing on our expertise in Elasticsearch, in Kafka, in Airflow, in Snowflake, and then of course Spark as well. But then also managing and building infrastructure using some of the cloud native principles or infrastructure as code principles, and also containerization and Kubernetes and all three cloud providers that you see there. So a lot of good work that our folks have been doing, and meetups are a way for us to present all these ideas to the world, to the public, and that's what we are doing today as well. So one last thing, if you are interested in working with us and exploring what the heck we are doing on a daily basis with our internal projects, with our external projects, we are hiring, and we are always hiring for great engineers and product folks, including some other cross-functional members as well. So please head out to egen.solutions/careers to know more about Egen and how it is like to be working at Egen and apply for a job there. So let's get started for today's topic. If you remember, last Thursday we talked about Project Reactor and Spring in order to understand, okay, hey, how to write reactive systems in JVM, right, or JVM world. Today we are going to take it one notch up and talk about from Kotlin's perspective, right, about how to use Kotlin and coroutines to write reactive systems. We again have Arif Lakhani here, a software engineer here at Egen. He has been working in this kind of fashion, this kind of reactive programming with one of our largest grocery customer or project at this point. So Arif, over to you.
Oh, thank you, Praveen, and thank you all for joining in again today. As Praveen mentioned, my name is Arif, and I do love backend systems engineering. We have this habit of sharing our learnings with the entire world via this meetup platform, and again, we're going to be doing the same thing. The focus for today is going to be Kotlin and how Kotlin is better than Java. So there's going to be a lot of Java versus Kotlin. I'm a Java fanboy myself. So trust me when I say this, that Kotlin does have a few advantages over Java. But we'll look at it from both perspectives and not just Kotlin's perspective. Also, Kotlin has this new idea of coroutines, which is basically concurrency with this new approach. We'll try to briefly look into that as well. Also, again, Project Reactor is again a big part of this presentation as well, because this is what Spring and Reactive Systems is based around. This is just a flavor of Kotlin that we'll look into with the Project Reactor. So that is still going to be a big part of the presentation. And then, of course, we'll have a live demo where I'll use Kotlin to do the same thing we did last time in Java, and then try and look on coroutines as well, and how coroutines are leveraged for building reactive systems as well. So coming to why Kotlin is Java dying, right? That is one question. So let's make that clear. Java is not going to go anywhere soon. There have been so many languages that came in, right? And they tried to change the status quo and claim to be the Java killers. None of them actually succeeded, right? And the amount of apps written in Java is just ridiculously high, and the legacy systems relying on Java, make it almost impossible for anyone in these days to claim that they can beat Java. I don't think Java is going to go anywhere. But that is why I like Kotlin. In my opinion, it is truly, again, my opinion, but Kotlin is far more versatile, and being this new, young, and shiny language, it is trying to address a lot of problems that come with Java, and that adds more value. And of course, looking at this, Java is catching up. Java is not going to sit there and let Kotlin take the market share. Of course, Java is catching up. And now Java has this very streamlined process of releasing a new build every 6 months with new features coming in. Another great thing about Kotlin is that it is fully interoperable with Java. So it is not trying to kill Java. It is trying to work with Java. And that means you can have hybrid projects where you can have both Kotlin and Java, and you can run the project on JVM, because Kotlin is Java based, or JVM based, I'm sorry. So that are a few reasons why you should be considering Kotlin. It is a fantastic language that works exactly like Java, and it is very easy for Java developers to get into the world of Kotlin, because it shares a lot of common principles with Java, and is trying to fix a lot of problems that come up with Java, right? So let's talk about advantages over Java. So this is the first point here is coming from the lead designers of Kotlin, right? So when JetBrains started the Kotlin project, the only motivation behind it was to make a language that the developers would love to code in, because it, I think, started in 2010, and around 2010, if you look, there was already a flood of all these new languages, right? Java was already there, Python was already there, we had C#, C, C++, JavaScript, all of that stuff. So give me just a moment. I forgot to put my phone on silent. I'm sorry about that. Yeah, so already a lot of languages in there. So JetBrains wanted to make a language that had something special. They already had the platform because JetBrains, being this big company of IDEs, they could push out a language and developers would try it because everybody loves JetBrains products, right? So they wanted to make a product or make a programming language that the programmers would love as well. And they did exactly that. They're trying to address all the issues that the programmers have, we as developers have in this language. The first very apparent fix that Kotlin brings is null safety. So if you've seen a null pointer exception, it's a very common issue with Java, and Kotlin just fix it. How they would actually fix it is what we'll look at during the demonstration. But there's this guy called Tony. I cannot pronounce his name, but Tony Hoare, I think. He was the guy who came up with the quick sort algorithm, and also the guy who introduced null references, right? And he calls this his $1 billion mistake, having null references in the first place. In Kotlin, the only possible way to get a null pointer exception would be to actually explicitly throw a null pointer exception, or using a special operator, which we'll talk about in the demo, of course. But in Kotlin, references can either be a value or nothing else. So you cannot have a reference that is null. If you want to have a reference that is null, you have to explicitly declare that reference to be null. And there is safe ways of going around nulls, which again possibly we'll look into when we come to the examples. Kotlin, being this modern programming language, uses all the modern constructs. So everything functional that we got with Java 8, right? Lambdas and all these high-level operators, map and flat map, and anything to do with streams and working with data as streams, opposed to the imperative approach. All of that is still there in Kotlin. The good thing is Kotlin's SDK and libraries are a step up from Java, so you don't have to do a dot stream each time you want to stream through the data. Kotlin has this natively built in. Java had to compensate coming late to the market with the Streams API because they wanted to preserve backwards compatibility and stuff like that, which we'll talk about again. But Kotlin has this natively. Also, Kotlin has extension functions. So these extension functions are a very new idea and a very new concept. Not exactly new, but a very interesting concept. So if you say have a class and you want to add functionality to that class, say you have a mutable list and you want to do a certain operation on a mutable list, the way you would do it generally with Java is to actually extend the list and call it your own list, and then use that own list and have that specific operation in there. With extension functions, you don't have to do that. You can extend a class or extend the functionality of a class without having to actually do subclassing, right? And this works for final classes as well. So that is one cool thing. And then we know that Java does not support operator overloading, but with Kotlin, there is operator overloading for unary and binary, both unary and binary operators. Kotlin compiler is very smart and does type inference. So you don't have to specify that a string is string because the compiler knows that it is a string, and you don't have to specify that 5 is an integer. The compiler would know that it is an integer. And as I mentioned, Java is catching up. So you already have this with Java 11, I think, has the var keyword. So Java is catching up there. The next good thing is named parameters. So in Kotlin, what you could do is all the functions can have named parameters. Now, how is that helpful? Say you have a function with 12 parameters in there, right? And you're writing this function and passing these arguments, and you don't know what these arguments are doing. With named parameters, it becomes easier to identify what each of these arguments are doing, as in you have a tag attached to all of these arguments. So if something is valid, that there will be a is valid tag and then a Boolean attached to it, so true or false. Again, we'll look at the thing in the example, and I'll reference it back to named parameters when we do. But it is a cool thing. Also with named parameters, also there is an option to add default arguments. So with Java, we did method overloading, right? So what we had is, say we have 3 methods, right? The first one has entire list of arguments. The second method has half the list of arguments. And then within the method, we fill the other half with default values, right? And then we have the third method where there is nothing and just entire default values. So Kotlin changed this. They said, why not just add default arguments within the same method itself? So there is method overloading. You still do that, but it gives you the benefit of having to have named parameters with default arguments. So you can provide, at the time of definition of the method, you could provide a default value to it. And during the invocation of the method, if you don't give that value, the compiler knows that it is going to take the default value, right? Then there is data classes. Data classes eliminate the need for Lombok. So anytime you do add getter, add setter, hash code, toString, overriding all of these methods, it's kind of redundant, right? It's boilerplate code. Nobody really wants to do it. Kotlin says, you know what, we know this is a very commonly used thing. So we'll give you a special type of class where all of this is already there. So they came up with the data class. And again, Java is catching up in this regard. In this regard, they also have a similar implementation of classes. I forget the name, but they do have this, and you can do this with, I think, Java 17. Kotlin removes static classes and static methods in support for companion objects. So companion objects could just be assumed as a direct mapping for static methods and classes. And we come to coroutines, right? Now, coroutines are very interesting. So we all know multi-threading is a concept in Java and a concept as general, but threads are heavy in the sense they require a lot of resources. If you remember from last time, I talked about context switching and all of that stuff. It's just a very resource heavy operation to do with creating new threads and running operations on new threads. So what Kotlin did is they created coroutines as a lighter version of this thread. So it is almost as if it is a thread. It just doesn't require as many resources as a thread would, and operates at the Kotlin level rather than operating on the JVM level, right? So again, it is a way of concurrency in Kotlin, and it is supposed to be very great. We'll look at how to implement Kotlin, and the results on coroutines have been stabilized and released out in the public very recently. So there isn't a very there isn't research out there on how good it is, but it seems to be very good. The Spring team loves it. They've used coroutines to integrate with Project Reactor, which we'll see coming up. But yeah, that is something to keep in mind. All right, what are the disadvantages of Kotlin? A very interesting slide. The first point is very interesting. Now, Kotlin, being this new language, again, it has this philosophy of continuous upgrades, right? So with Java, because it is a legacy language, it has to maintain backward compatibility, because we all know what happened with Python, right? When Python moved from Python version 2 to version 3, they effectively just broke all continuity. And breaking continuity means the community will stick with the older version because there is legacy code, and no matter how hard we try to modernize, sometimes it's just not possible or not in the priority to get it to that new specification, right? And why do these breaking changes exist in the first place, right? Because there is always, no matter how good the organization is, no matter if you're a developer for Oracle and writing Java that others are going to use, you always make mistakes, right? And these mistakes are not even mistakes. It could be just design principles that made sense back then, but today you're going to implement a feature that does not particularly fall in line with the design principles and decisions you made earlier. So Java, again, being this legacy language and wanting to always preserve backward compatibility, had this or has this problem, very real problem, that anytime they want to do something new, they have to compensate for all these years of versions of Java. They have to make sure nothing breaks apart. Because if it does, then we land up in the situation of Python, where people are not going to migrate because they just love the current version and how it works. That seems to be the case with Java 8, but Java is currently encouraging everyone to move forward, right? And they have this again release cycle where they provide long-term support versions and stuff like that. But with Kotlin has gone the other route. They say that they're not going to if need be, they will make breaking changes. So if there is a bug that is troubling Kotlin, or if there is a new feature that is not in line with the expectations or designs of the previous version, they will make a breaking change and release a new version. They have a 1-year support cycle, as in if the previous version is the one you're using, it could be used up until a year, and then they'll stop supporting that version. And if something happens with that version, then you're responsible for your code. So they are betting on the devs to be proactive enough to keep updating their code base and using the latest version of Kotlin out there. Now, since 2010, there haven't been a lot of instances where Kotlin has done something like this, where they introduced breaking changes. So we have to look at from that perspective as well, that they are making or trying their hardest to not deliver breaking changes when possible. But if need be, again, they would do it, right? The other thing is Kotlin compiler is just a little slower than the Java's compiler. So we all know there is a level where the code is compiled into the bytecode, and then the bytecode runs on JVM, right? So this compilation process, Java is faster than Kotlin, because Java, doesn't do a lot of magic tricks, right? Kotlin, on the other hand, it has a lot of tricks up its sleeve, and it can perform a lot of things that you would rather not perform, right? Iterations, Lambda functions, all of that cool stuff of a modern programming language takes a little bit of toll on the compiler. But the good thing about it is that the code compiles only once and runs multiple times. So runtime, it's all going to be the same. Once it converts into bytecode, it doesn't matter if it's Java or Kotlin, it's going to run on JVM. It is all going to be the same thing. But the first compilation process will be a little slower. And it's not a lot. I think I read some article where it says 3 seconds or something like that. So not a lot of slowness there to be worried about. And based on personal preferences, some advantages of Kotlin could be potential disadvantages. So if you are planning to make the switch over onto Kotlin, your team must agree on all fronts that Kotlin is something they want to take up. And if the team members are not ready for a programming language like Kotlin, because if you are used to Java 7 and Java 8, where there is imperative style of programming, you write a lot of classes, a lot of boilerplate code, and if that is the place we are coming from, it is not bad, right? The imperative style of coding is not bad. I'm not saying it's bad at all. It's just that getting used to this functional way of programming and this new way of programming might be a little bit of a learning curve, and people might not like it at the very first time. Although I personally think Kotlin's code is more precise, concise, and maintainable. Yeah, that could be a disadvantage if you're coming from the Java 7 world. And again, Java 7, there's nothing bad about coding in the imperative style if you're used to that approach as well. All right. Now, Spring loves Kotlin. So we'll talk about why Spring loves Kotlin. Not why, because it's just obvious, because Kotlin is a new programming language, and Spring team, being this fast forward thinking organization, wanted to implement Kotlin now that Kotlin is interoperable with Java. But Spring now has native support for Kotlin. So if you were to start a Spring project, you have the choice natively to start with Kotlin rather than Java. Java is still supported. Java is not going anywhere. Spring acknowledges the fact that Java is important, and they have Java in there. And all of their legacy code is, of course, in Java as well. Kotlin language supports Kotlin language support documentation is now available. So if you go to the Spring website and start reading about Spring and different Spring projects, you'll see documentation support for Kotlin as well. So previously it was just Java. If you wanted to do or look the documentation up and see for some examples and real-time use cases, right? you'd see examples always being written in Java. So the Spring team is making an active effort to convert all the documentation to Kotlin as well. They've already done this for web MVC. So if you look up the web project from Spring, you'll see Kotlin examples everywhere. They're doing this for data as well, Spring data as well, Spring security as well, and the Spring team, I think, has promised a certain deadline or timeline where everything will be full language support documentation will be available for Kotlin as well. And Kotlin coroutines are fully interoperable, as I mentioned, with reactive types Mono and Flux. So that is one big indication from the Spring team on how much they admire the Kotlin ecosystem, because they've made this active effort of having to integrate with this Kotlin coroutines library and make it functional with the project Reactor. Okay. All right. So the next few slides are from the previous presentation. I just want to go back and revisit our concepts of reactive programming as well before we go into the demo. So we'll talk about what reactive systems are. And the simple answer to what reactive systems are is that any system which is not blocked or does not need to wait for the IO to finish is a reactive system, right? So if we don't wait for the IO to finish, what do we do on the particular thread? You can see the diagram here, requests coming in from the left to a Spring Webflux application, which is reactive. It follows a thread per request model where each request is carried out on a thread. Threads can be blocked because of IO. So whenever a thread goes into the IO state, it cannot do anything else unless the IO returns. And IO times might vary based on various factors, right? And we are effectively wasting that time while we wait for IO. So the better approach would be to release that thread back and then accept more requests on that thread while we wait for IO to finish, and then associate a callback with the IO. So as soon as the IO finishes, there is a callback to the thread pool, and then we resume our processing from the point where we left. So whenever there is IO, stop at IO, register a callback, send the thread back to the thread pool. As soon as the callback calls the thread pool again, we start or resume the processing from where we left it the last time. Now, of course, this is a lot of work, and it is a lot of ground level implementation where we have to make the thread pool, guess the size of the thread pool, what works the best, and then also talk with the operating system about all of these threads and register callbacks, have a mechanism that callbacks calls the thread again. And again, all of this ground level implementation stuff is not something the application level developers would like to do, right? We like solving business problems. We want to empower the business, earn more money, and not do all of this groundwork, right? And that is what the Spring team exactly thought, and they came up with this framework that does all of this. So everything that needs to be reactive and non-blocking has already been implemented by the Spring team, and they gave us this very sleek framework to use. So we can get started in the same way we do with Spring Boot, right? So traditional Spring Boot with reactive, it is going to, the API is more or less going to be the same. We just have to make a few different adjustments and add a few different new data structures in there to support the reactive nature of things. But that is what Spring team has done for us, and we'll look at the demo, and I'll go over the data structures as well, which were introduced as a part of the reactive manifesto. This diagram here is again the same thing, just that the name of the request has been renamed as event. So as soon as a request comes in, we register that request with a callback. If there's an IO request, when the IO request finished, it transfers it back to the event loop, and the event loop then continues the callback execution and returns the response to the requester, right? This diagram, you might have seen it with different technologies. JavaScript on the back end, if you've used Node.js, has a similar approach of doing things. Difference being Node.js, I think, only has a single thread approach, whereas with Spring Webflux, you can configure the number of threads you want. So that is one good thing about this. And then now we have to understand that reactive means you are reactive all the way through, right? Because if the thread gets blocked at any point of time within your entire life cycle of the thread, then it is a blocking thread, no matter uh, if you were to do reactive on the top and then you block it at the DB level, then that's just not going to work. So the Spring team understood this point, of course, and they came up with the entire stack that is reactive. So NetE is a community source project developed which supports fully non-blocking IO. The Servlet 3.1 specification, which came out with Java 7 Enterprise Edition, so a long time back, supported non-blocking IO operations as well. But as you could imagine, with Java 7 and Servlet 3.1, the non-blocking IO specification was a little different. So there is a reactive stream adapters layer in between, which acts as a bridge between Spring Security Reactive, which we'll talk about, of course. But Spring has its own non-blocking reactive implementation with Project Reactor. So someone had to bridge the gap between the non-blocking nature of Servlet 3.1 and Project Reactor. So there have been developments with reactive stream adapters, and then based on Project Reactor, we have Spring Webflux. On top of Spring Webflux, or on top of WebMVC as well, if you look on right, Spring has the security project, which is used for OAuth and stuff like that, right? So Spring team had to revamp the entire security project as well to fit into the reactive framework. So they came up with Spring Security Reactive. We have Webflux in there. And then finally at the bottom, we have R2DBC. R2DBC is the larger form would be relational reactive database connectivity. So R2 and then DBC, database connectivity. And it supports a lot of databases. So right now, PostgreSQL is GA, so it is available to use. And then Mongo, Cassandra, Redis, Couchbase, a lot of other database providers have also come forward and are currently actively working with the Spring team to come up with adapters for their particular database, so that this technology can be used with their databases as well, right? All right, it's time for the demo. I'm going to stop sharing here for a while and set a few things up. Okay. So I'm going to take us through what we did the last time and then try and convert the same thing into Kotlin, right? So here's what we did last time. This is our car tracker project, and this is the reactive version of it. So if I were to open a controller, this is an API just for IoT of vehicles, right? So you can register a vehicle in here, and then all the registered vehicles, what they could do is send readings, right? And readings coming from the sensors. So with these modern cars, right, assume of it as a Tesla. Tesla has a lot of sensors, and these sensors are sending readings onto this API, and this API is going to check those readings and see if there is anything wrong with the car. If there is, it will create an alert and store it in the database, right? So a very simple API registering vehicles, and then basic CRUD operations on the database with this, a readings controller and an alert controller. And if you remember, we used the reactive CRUD repository instead of the regular JPA repository, right? And if we were to go into build Gradle and see here the dependencies, we had Webflux, we had R2DBC, Lombok, and then R2DBC for PostgreSQL, right? So we are going to take this project, right? as reference and try and convert this into Kotlin, right? So for which I am going to go to start.spring.io and just start a new project, right? So let's go start.spring.io, say com tracker Kotlin, want Kotlin, be a Gradle project, Spring 2.5.4, tracker, right? I'm going to leave that there. And dependencies, say Webflux. Of course, we're going to be doing reactive, and then R2DBC. And we don't need Lombok anymore. As I mentioned, we're going to use data classes from Kotlin. So we don't need Lombok anymore. What else do we need? Yeah, I don't think we need anything else. PostgreSQL, yeah. Yeah, I think that should be enough. We'll add more dependencies if we need them. And then I'm going to generate this project on the desktop, of course, and unzip this. Desktop, Kotlin, is this the right project? Because I was trying to do this before the presentation as well, of course, and I might have mixed two things up here. Let us verify. Yeah, so our thing is named car tracker. This is our project. Let's open this up here. Yeah, cool. So what we want to do is, first of all, let IntelliJ load this thing up, and I'll add dependencies for Swagger in there. Let us wait. Okay, the project is loaded up. So let's quickly create all the basic skeleton of this thing. We need a controller package, a service package, a repository package, finally a model package. Let's start off with the model, right? So I'm going to say Kotlin class, and I'm going to say vehicle, right? We need the vehicle registration, so we need a vehicle. Generally with Java, what you do is you say string name, ID, or whatever, right? But as I mentioned, with Kotlin, you have something called as a data class, right? So what is this data class? So you just say data, right? And then notice it immediately starts complaining that it must have one primary constructor, right? And the primary constructor, the way to do a primary constructor in Kotlin is to give it a brace right here. And then you could either leave this like this, or just within the constructor say what the properties of this vehicle are going to be, right? So I'm going to refer back to the original project and see what the what the properties look like. Second. Yeah, I have it here. Okay. So all of these properties, I'm going to just paste them in here, of course. I'm going to waste time writing all of this stuff. Okay. Now this data class, and this is the constructor. This is also the default constructor. So whenever I create a vehicle object, I need all of this, right? Except here, because here, as you can see, I have given it a default value of 0. Now, when I create the vehicle object, I can skip here if I wanted to, because there's a default value to it, but all of the other things are necessary. So what do you do if you want to override it or have a new constructor or have a overridden constructor, right? So for that, what I'm going to do is I'm going to copy all the objects or models that are required and paste them here. So we save some time, right? And look at a particular object which has a default constructor. Okay, it doesn't, but you can Should have been 1. Okay. So what you could do is, if you wanted to have a default constructor, is you could say constructor, right? And then here implement anything that you want with the default constructor. That is the way you override constructors in Kotlin, right? But in this case, I don't think we need any default constructors. Although if you want, as in this case, right, you can have default values so that you don't have to pass these values when creating these objects. And anytime you create these objects, you will the default value will apply, because constructor is also a method. And as I mentioned earlier as well, with methods you can have default values and named parameters. So all of these parameters are named. The parameter name is same as the name of the variable. So whenever I'm passing an ID, I can name it ID and then pass it to look at that. Going too far ahead here. Let's create a controller, right? Let's say vehicle controller, right? And what we want is, okay, let's actually compare it with Java this time around. So here is the Java controller, right? And because Kotlin is developed by JetBrains, which is the company that does IntelliJ as well, what you can do is copy your Java code and just paste it in a Kotlin file, and IntelliJ will convert it into Kotlin code, right? Provided it is not the best conversion possible, but it still tries its hardest, right? And it does a pretty good job as well. So if we were to look at the function definition here, we had the signature as public, mono vehicle, find by ID, and then function arguments, and then the function starts, right? With Kotlin, function is just function, and then the return type is here on the right side, as is with many programming languages. And the question mark you see here reflects whether or not this vehicle can be nullable, right? So whenever you declare, let's go back here and talk about this. Whenever I declare this variable val ID string, this means that the ID can never be null, right? It can only be a string. It can never be null. If I wanted to, I could say this, right? A question mark, which means the ID can either be a string or it could be a null, right? So right away, you can eliminate or kind of defensively code against the null pointer exception, where you for sure, when you know that the ID is never going to be null, you just don't allow that null to happen, right? So that is one great thing. And then let's come back here and just take all the question marks away from here, right? And this is a private variable within the vehicle controller. With Kotlin, dependency injection is very easy, right? So this is why Kotlin seems like a match made in heaven with Spring. Dependency injection is as simple as that, right? Now, provided with Lombok, you could do private final variable and then say required args constructor. But with Kotlin, it is that much more easier, right? You can have a class and just, this is injection. It will find the bean of this type and inject it into this class when it is trying to create an object, which reminds me, this needs to be a REST controller, right? So that is a REST controller. Let's import vehicle in there. Actually, I should rename all of these. Copy pasting. I did not actually do the package name correctly. Okay, cool. So imported vehicle in there. Now it says that it cannot find the bean of type service because we have to still create the service, right? So let's create the service. Okay. So within iVehicle service, which is an interface, of course, what do we need? Let's come back to our Java project and see what we have here. We have 3 functions. We're going to simply copy these functions and again, use the magic of JetBrains to try and convert these into Kotlin code. Again, the code is simple. It just is going to replace the function signatures with what aligns with Kotlin. And let's just import the vehicle class here. What is this kind about? Okay, a function insert without the body must be abstract. Okay, this needs to be an interface. Sorry. Cool. So this is our interface, and let's go ahead and add an implementation for this thing, right? So we'll say new Kotlin class, vehicle service, simple. And then let's go ahead again to our Java code and copy the service layer back into Kotlin code. Again, let's just do the dependency injection from the way Kotlin wants us to do it, right? Replace all the question marks here because we don't want nullables. And implement this class as well. So create class repo, extract to a file, say repository. Here, it is actually going to be an interface, of course. Let's mark this repository right away. And then the magical part where we, okay, now see, this is me trying to be a Java guy, but with Kotlin extensions, right? So if you want to extend something, you do it or implement, right? So extension and implementation. So this is an interface. It is going to extend another interface, but if we were to be a class implementing an interface, it would still be the same thing. You just use this operator, colon operator, will give you the same result as extends or implements. So we are going to say reactive for repository. Of course, this is going to be vehicle repository, and the ID is a string, right? So that is our repository. We should do the same thing for service as well, because I did not extend the service class here. So vehicle service. So this in this case means implements, and in the other case it meant extends. Now the functions have started complaining. It's because it needs the overwrite keyword, right? So we'll add the overwrite keyword in there. With Java, it's an annotation. With Kotlin, it's a keyword. Just a very small difference, right? And now this says that, okay, the names don't match with, yeah, so in here it's v. Now name parameters is important, right? So if I have a v in my interface and vehicles in my implementation, then it is not complaining, but IntelliJ recognizes this and says that you'll have a problem going ahead with named parameters if you do this. So named parameters are not something you have to necessarily use. You can either choose to use them, or you can still invoke your functions as normal Java functions, like I'm doing in this case, right? So save all of vehicles, right? But I could do, what I could do is I could say what the parameter name is. Okay, this is coming from Java's API, so not here, but in the controller. So either use name parameters or don't. But if you're using name parameters, you have to make sure your interface and implementation match in terms of your variable naming. So I'm going to make this vehicles as well, so that we don't have a problem if we use named interfaces. Oh, sorry, named parameters, right? So let's go here and you look at this. This is me not using named parameters. But if I were to use named parameters, I just have to find what the parameter name in here says. It says win, right? So win equals win. That is all I need to do. And IntelliJ is smart, of course. IntelliJ, again, the parent company is the same that developed Kotlin. So it knows when I'm using a named parameter, and it instantly highlights the named parameter. Now this, again, as I mentioned earlier as well, gives you a brief insight into what you're passing. So if you have 20, 30 arguments, it is easier to use, although it's in the first place having to pass in 20, 30 arguments is bad by itself. But if you are ever in a situation where you have a long list of arguments to pass, named parameter is going to be a very good thing to use. All right. That is that. Okay. So we have effectively implemented. Why is this still complaining? Okay. To mark this as a service. Okay, cool. So we've implemented the CRUD controller for vehicles, right? And this is all in Kotlin, right? But if you look at this, it is still using Mono and Flux, and that is from the reactive systems. And we did not talk about it. So let's talk about Flux for a while. Flux is a reactive data type that comes from core publisher, which comes to publisher, and publisher is a part of reactive streams. Now, this reactive streams was originally developed by engineers from Netflix, Lightbend, and Pivotal. So these guys came together and they said, we have to build reactive systems because it's just bad that on the back end we're waiting for I/O. So they came up with the idea of reactive systems, and they just came up with 4 different data structures. So they said there'd be one publisher, there'd be one subscriber, there'd be one subscription, which we can see here. So there's a subscriber and there's a subscription object, right? And they said there's going to be another object that does both publishing and subscribing. So they defined all of these 4 data structures, right? And then they parted ways. Netflix came up with their own implementation on top of this reactive specification called RX Java. Lightbend did their own thing and came up with Akka streams and all other reactive streams. And then Pivotal came in and they took this reactive specification and built Project Reactor on top of it. So Project Reactor basically adds high-level functionality on top of these 4 basic data types, right? Because these basic data types don't do much. Project Reactor, what it aims to do is, as with Java 8 streams, right? We have a lot of high-level operators like, say, stream mapping, flat mapping for each, and iteration through the stream itself. So the main aim of Project Reactor was to add all these high-level operators so we can work with this low-level data types, right? But is that enough, right? No, it is not. We still need a framework like Spring Boot to build REST APIs which are end-to-end. So what the Spring team did was they introduced Webflux, which internally uses Project Reactor, right? And they developed the whole API for which is basically equivalent to using Spring Web MVC. So Webflux is basically reactive web MVC, and it uses these 2, Mono and Flux. So Mono is very similar to Flux, right? It also extends the core publisher, and again, the base is publisher. The only difference is that you would use a Mono when you know that you are expecting a single object, but you would use a Flux when you don't know how many objects you're expecting. So if it is a list of vehicles that you're expecting, then that would be a Flux. But if you're expecting just one vehicle, then it'd be a Mono, right? So this is about the reactive specification. Let's also talk about the coroutines, right? And how coroutines fit into this entire thing. I said coroutines are, incredibly interoperable with the entire thing, with the entire Spring ecosystem, right? So what I'm going to do is keep this project aside and bring in something that I already have ready to share. 1 second. Yeah. So this is the end implementation of what we just started. And if you were to implement all the controllers and all the servers, this is how it would look like, right? So we'll talk about coroutines from here. You can see coroutine scope here, right? Let's start from there. 2 new things: suspend function and coroutine scope. Also note there is no return on these things, and without a return statement is how we're returning stuff here. Okay, So the suspend function, suspend keyword is necessary for any coroutine to launch. And as I said, coroutines are lightweight threads, and these lightweight threads are indicated using the suspend keyword. So these functions can be suspended without actually blocking the ongoing process, right? What is coroutine scope? So if I don't do the coroutine scope, right, I can still work without this, right? But then what would happen is we would land into unstructured concurrency. Now, what is unstructured concurrency, right? That is a very interesting topic to discuss, because this is where all the power of coroutines comes from. They have structured concurrency and then they have unstructured concurrency. So with respect to threads, if we talk about multi-threading, right, what do we do in multi-threading? We create threads and we assign tasks to those threads, and those threads, when they complete, we can either join those threads, meaning we wait for all the threads to complete and then exit the main thread, or we can just exit the main thread and these threads can be working in the background, which is most of the time, in most of the cases, the problem for leaks, right? So memory leaks and stuff like that happens when you do this sort of thing, unstructured concurrency. So with Kotlin, the way to do structured concurrency is to actually launch this in a scope, right? So what is the scope? The scope is what defines that whatever happens inside of this function, how many ever routines or coroutines I create within this function will all end if this function ends, right? And if there is an exception thrown within any of the coroutines within this scope, all the coroutines will stop immediately after that, and the function will end. While on the other hand, if you don't define a scope, then the coroutines could be running, right? And if there's an exception, that still be running. And although these coroutines are lightweight and don't consume a lot of resources, at some point they still consume resources, right? It's not like it's free and you can use them forever. They still require some sort of resources, and over time, if you don't address the issue of concurrency, and if there is a lot of leakage, you will run out of memory. So coroutines has this concept of scoping all the routines together, and anything that comes within this function will be within the scope of coroutines, right? So the better example for looking at the coroutine scope would be to actually come to this controller right here and look at this method, add readings, right? So this add readings method, if you were here last time, you remember that what it does is it takes the sensor reading, right? It finds what vehicle this reading is for. So we get the vehicle info from the database at this point. And then we look at various factors and create alerts if the alerts are necessary, that is, of course. And then we save those alerts in the database. Now, saving alerts in the database is also a blocking process. And if you go sequentially, right, you might take a little bit more time. So this is a very good use case for utilizing coroutines and launching them on separate coroutines of their own, right? So here you can see I've used this launch keyword to fire up this coroutine and do this particular task. Now it is again essential to remember that this is scoped. This is scoped within this function, and this function is again scoped within this function, right? So if there's any problems within this function, all the other coroutines will also stop immediately after that, right? So, and these functions, of course, wait for all the coroutines to finish anyway. And they wait in a special manner, so they don't block, they are suspended. So the suspend keyword is very important here. Suspend doesn't necessarily mean block. Suspend means they're not actually, they're waiting, but in a special manner, they're not blocking the resources. That is something that internally, the implementation wise, Kotlin has done. Kotlin has implemented it in a way that it doesn't really block or use any resources, but it remains suspended for a while, right? So that is the example for launching it. So what if I wanted to, for some reason, right? What if I wanted to launch it outside the scope of it? Now, there might be situations where you would like to remove the scope and go outside of the scope to launch stuff, right? So although not recommended, by the Kotlin team. You can do global scope dot launch or something like that, I think. Yeah, global scope dot launch, and then you have to provide a coroutine context and do all of that stuff. You can provide a coroutine context, which is basically a few things that define the life cycle of that coroutine. But if you want to just use global and the defaults, you can do this. And if I were to go into global scope, it would say that it is not recommended that we use see, right here it says do not replace global scope coroutine scope dot launch or somewhere. I've read this. You have to take my word for it. It is not good to use global scope dot launch. It is just a bad practice. So use coroutine scope unless it is very necessary. So of course there might be legitimate use cases of using this, and when the use case arrives, you can use that. But for now, it is going to be launched. Now the interesting thing, all of this is okay, but if we come back to the controller, we can see that there is no more mono or no more flux. Instead, we see a new type called flow, right? So whatever happened to mono here? How are we returning reactive type if there's no mono here, right? So a very interesting question, and there is no return type as well. That is because anything that is a coroutine function or a suspend function, if that is the last line of your function, Kotlin does not require you to have a return statement. So if this is the last line of the function, this is considered to be the return statement by itself, right? So let's go here and see why this is no more a mono, right? So if I were to go into this function, this is vehicle service, okay? And we have vehicle repo, right? So let's go into vehicle repo. It extends a reactive code repository, right? So the same thing we did. But here's something interesting. And again, in Kotlin, as I said, it is a modern programming language. You don't need braces when you can finish your code in one line. So this could have been like this, where I put this in there. So you could do this, right? But again, as I said, modern programming language comes with its own benefits. You can just have clean, precise coding. Just say equal to and write the code in here. Now find by win, if I go within this function, this is from again from the reactive repository. It returns a mono, right? It returns a mono, but I said coroutines are fully interoperable with the Spring API, Reactive API. So the Spring team has come up with a method that would convert this into coroutine types. So coroutine types are generally of two types. Again, similar to mono and flux. So if you are using coroutines, you don't need to specify a mono. That is to say that the compiler understands that it's a mono, right? But if it is not a mono, right, then you would use flow. So either you wait for the first one, right? And this wait again is a suspend function. So it is not blocking, right? It is not a blocking function. It is a special kind of function which suspends itself while it does other things. And then whenever the result is ready, it will come back with that. And similarly, you can do as flow as well, which basically does the same thing. It returns a flow. Flow is just equivalent of flux in Kotlin. So the question would be, why use coroutines in the first place, right? And why is it so important that we understand coroutines? So with coroutines, with the main aspect of all of this is that with the reactive API, right? The programming construct has changed a little bit. There's no more imperative programming. The programming we're used to is the imperative way of coding, right? We go sequentially, step by step, and then do all of that stuff. With reactive programming, there's a lot of pipelines and streaming the data and trying to understand how that works. It could take a little bit of time getting used to that. And that is okay. But Kotlin's coroutines, you can still do your sequential programming, right? As in, we just saw within this readings controller or reading service example. Where did that go? Yeah, here. we saw that this is the way we would do it regularly as well, but instead we just launch it on a different coroutine. With the previous example, right? Let me go back to the Java example. Yeah. So you can see this vehicle report or find by ID gives back a mono, then I map it onto a mono and then use this SDK method to actually save this, right? So I have to think of this in terms of a data pipeline and a stream and the asynchronous stream of data. That is a small shift in the paradigm of programming itself. But if you were to come back here, there's no shift in programming paradigm, right? This is still a vehicle, and I start working with that vehicle object, right, as I would with any other say Java 7, right? And then just launch it on a different coroutine. Again, nothing that I'd change here except for the fact that I'm launching this on a different thread. But you lack this level of control and granularity with the traditional reactive systems and JVM based approach. Coroutines just adds this new flavor and new way of doing things, which is in a sense could be easier for us to deal with, right? So yeah, that is the entire coroutines aspect of it. I think I've covered everything that I wanted to. So yeah, I'm going to stop sharing here and come back to the presentation. Just 1 second. Okay. Right. So completed the demo part. Takeaways. Reactive is better. I have a comparison link that I'm going to open here and also put in the chat box here. You can refer to this. This guy, he compares all the different possible combinations. So MVC with JDBC, MVC with R2DBC, and of course, needless to say, Webflux and R2DBC come out on top always. So he compares all of these response times, throughput, process CPU usage, and memory usage. And again, this comes out on top each time. Review that article, it is very nice. And then certainly shows you the advantages of using all of this, right? Coming back to our, did I just remain on the same page and talk about an article? I think I did.
Yeah.
I'm not sharing the other screen. Yeah, sorry for that. I on my screen I was able to see the article, which is now that I think about it, very funny. Okay, I'll share the article once we're done with the presentation on the screen, and we'll go over it. We don't need to worry about the lower level abstractions, reactive abstractions with Spring Boot and Webflux, because all of that is done by the Spring team anyway. We can scale more with the same number of resources and save costs on cloud. So if you were to think about it, if you're not using or if you're blocked on the same thread, you're wasting CPU time, right? And CPU time is very important on cloud, because that is what we're paying for. And if you were to not block on that thread and come back and use that thread more efficiently, we are not just using the thread more efficiently, we're using saving money on the cloud, right? So we can scale more within the same number of resources. About Kotlin, Kotlin is of course, in my opinion, better and easily readable. And this is coming from a Java fanboy. I'm a big supporter of Java. I love Java. Java is my bread and butter. But still, Kotlin is very futuristic and helps us a lot as programmers. And coroutines, I'm no expert on coroutines at this point. I've just started using them and doing a little bit of stuff. So exploring coroutines for a better approach to reactive systems is something that is a takeaway for me as well in this case. It kind of brings a new flavor to the reactive systems and can be very useful in some cases. So that, and the other thing is R2DBC and stuff like that. They're still in early stages. So all of these developments have been in the past 2-3 years. Not a lot of resources out there. There are a lot of resources, not to say that they're not resources. There's a lot of good resources on learning all of these things. But when you go to production with these things, you want to be careful about a few things. I mean, um, yeah, just a word of caution that this is not as mature as something like Spring Data JPA, which is being used for a long time now. So yeah, just keep that in mind when implementing this at production stages. But POCs and self-learning projects should be great to do something like this, because this is going to be a big thing, I think, in the next 3 to 5 years. uh, all right, last slide. Thank you all for attending. Was great talking to you guys about all of these things. Thank you, Praveen, again for organizing all of this and putting this together. And Josh Long is a guy from whom I've learned a lot of things about reactive programming via YouTube. So he's a virtual guru for me. He doesn't know who I am, but I know who he is. Steve and Gagan have been my excellent teammates who've been working with me on this stuff now for 3 to 4 months, I think, and we've been learning and growing together. There've been a countless number of times that they've helped me understand the concepts of reactive programming in general, Kotlin, and a lot of that stuff. So thank you guys, and let's stop here for questions. No questions.
Okay.